We're solving problem 3 from the 2024 F equals MA exam. A simple bridge is made of 5 thin rods rigidly connected at 4 vertices. The ground is frictionless so that it can only exert vertical normal forces at B and D. The weight of the bridge is negligible, but a person stands at its middle, exerting a downward force at vertex C. In static equilibrium, each rod can be experiencing either tension or compression. Which of the following is true? And in case if you're wondering, all of these are in, it's asking the answer choices in tension. So for A, it would, on the test, it says only the vertical rod is in tension, but I don't have that much space and time to write it, so I just simplified it down like that. Now, we have these, and our first step of motion is to really illustrate all the forces. We know that this dragging down force is just the force. Okay. So let's just illustrate point A. This is the top of point A. And, well, we know that this segment is pulling down because the person is standing on, or right there, that corresponds to point C. It would pull this segment down. And, well, so we have that. And there would be 2 other segments that would correspond to these sides, as the sum of the forces on these side would have to be equal to this pulling down force, as it is in static equilibrium. So this means that, well, if we have these forces, they have to sum up to this one, and they cancel out nicely. Now let's look at points B and D. If we look at point B here, well, it certainly exerts a normal force upward, and it exerts a force back, and it exerts a force like this to our point A, where let's say A is right here. And since A is forced down on that B, we can say that our segment AB is in compression. It's pressing down on each other. So we can have the similar logic with D. I'll draw it out here on D. There's an arrow here, and then the normal force. Now we know that these diagonals are not in tension. They are in compression as they are being pushed against each other. Now these horizontal segments are pulling out and out on their opposite directions because they have to cancel. This means that these segments are in tension. And we see that because if someone stands at point C, it would probably very slightly curve inward, so it would not produce a flat line, but a sort of small triangle. And now let's talk about point C. Well, since there's the person standing directly above it, there's a force below, so we know that that is in tension as that rod is being pulled. So we know that it can't be the verticals, it can't only be the horizontals, there's no diagonals, and it can't be all the rods because we just said it's not the diagonals. So therefore, our answer for this problem is D. The vertical and horizontal rods are in tension.